All right, the method of solution. So how we're going to solve exact differential equations. All right, now this is an alternate method. Sometimes this is the only method that we can use. Other methods we can notice, oh, I could have used separable equations. Oh, hey, I could have solved this because it's a linear first order differential equation. All right, and then if that's the case, go ahead and do that. But again, this is just another method of how we can solve differential equations. So the first thing you want to do is you want to check to see is m is taking the partial derivative of n with respect to y equal to taking the partial derivative of n with respect to x. If it's equal, it's an exact equation, and then we can work further down. And so for 2, we have, what we're going to do is we're going to find our f, and then we're going to take the integral of m dx. And whatever that integration is, we're going to have plus, gy or plus hy. Right? After we do that, we're going to take the partial derivative of f with respect to y, or we're going to take the partial derivative of f with respect to x. It's all dependent upon which one we decide to choose first. If we decided to, take the integral of m with respect to x, or take the integral of n with respect to y, then we're working on, one of these two sides. So if we took it with, n, or I'm sorry, if we took it with m, then we have the partial of f with respect to y. So we're going to then, after we've taken the integration, we're going to take the derivative of that, but with respect to y, and set that equal to n, because we knew that the partial of f with respect to y is equal to n. Same thing here. If we started with n, then we're going to take the partial of f with respect to x and set that equation equal to m, whatever m was. Then we're going to solve for g prime of y, or we're going to solve for h prime of x. Integrate both sides to find g of y or h of x. Replace g of y or h of x. And then 7, we're going to be finished. We're going to write f of xy equals the stuff that we found is equal to c. So our constant for this is always going to be what we're equal to. All right, so our constant should not be we should not write it f of xy equals stuff plus c. We should write all of our stuff is equal to c. And then we have the initial value. So what we're going to do is I'm just going to, I'm going to just keep going up and down so that you can see, okay, this is step 1, this is step 2, and so on and so forth. All right. And then some of you might realize, oh, hey, this is kind of how we checked to see if we were dealing with a conservative vector field, where we had a vector field which was the partial derivatives of a function, and we worked back to see, okay, what was that original function. So, example 1, solve the following differential. So we first want to make sure that it's in, this form. This is the only time I'm going to write it. Partial of f with respect to x dx plus the partial of f with respect to y dy equals 0. So it's got to be in that form. All right? So it looks like it's of that form where there's our m and there's our n. So the first step that we're going to take is we're going to go ahead and take m, and we're going to take the derivative of m, but with respect to y. When we do that, we get 1. Then we want to take n and take it with the derivative with respect to x. And when we do that, we get 1. Because those match, we have an exact equation. And now what we're going to do is we're going to go ahead and work backwards. So it's all up to me. I can decide which, I want to deal with. Do I want to deal with m or n to get back to the original equation? So I want to find f of xy. So what I'm going to do is I'm going to integrate the, let's just go ahead and do m, plus the others. So we always know that then it's also going to give us, what our g of y was. So when we integrate m, we're integrating 2x plus y dx, and then we have that plus g of y on the outside. And so we integrate 2x, we're just going to get x squared plus xy, and then plus our g of y. right? So now we have f of x. This is what our solution is going to be, but we got to find what our g of y is. All right, so now to find g of y, what we're going to do is we're going to take the partial derivative of f with respect to, in this case, y. So here's our function f. We're going to take that derivative with respect to y. So the derivative of x squared is just 0, plus xy, which is just x. And then plus gy is going to be plus g prime y. Now, this should be equal to, if you recall, the partial of f with respect to y is equal to our other variable, in this case, or not other variable, other function n. So I'm going to set this equal to n. So x plus 6y, there's that function n. All right, now I'm going to solve for g prime of y. When we do that, we're going to get g prime of y is equal to just 6y. And now we're going to integrate both sides. So integrate both sides, but this time with respect to y. And we get gy on the left-hand side. On the right-hand side, we're going to get 3y squared. 3y squared plus c, we could write. I'll write it there, but just so you know that c is always going to go on the other side. So we found our gy. We're going to replace that into our function. And so we have our function f of x, y is equal to x cubed plus xy plus gy, which is 3y squared, and then plus c, but again, our c is always going to go on the opposite side, so that's equal to c. And there is our solution to our differential equation.